continue discussing section 11.2. Today we will discuss very important series, so-called harmonic series. This is example 9. So harmonic series, this is a definition of harmonic series. And summation of n goes from 1 to infinity, 1 over n, or it just equal to 1 plus 1 half plus 1 third plus 1 fourth plus 1 fifth and so on. And we will show that harmonic series are divergent. Here is a proof. So n goes from 1 to infinity, 1 over n is the same as 1 plus 1 half plus 1 over 3 plus 1 over 4 plus 1 over 5 plus 1 over 6 and so on. Let's go up to 1 over 16 plus 1 over 17 plus 1 over 32 and so on. What we do now, we group together third and the fourth term, then we group those two terms, then we group next 4 terms together. This one is 5th, 6th, 7th and 8th. Then we group together next 16 terms, 8 terms, sorry. And then 16 terms and so on. And we observe, pay attention that 1 over 3 is strictly more than 1 over 4. So if I replace 1 over 3 by 1 over 4, I get that 1 over 3 plus 1 over 4 is more than 1 over 4 plus 1 over 4, which is in sum 1 half. Here in the next group, I replace 1 over 5 by 1 over 8, which makes this smaller, right? 1 over 6 is still bigger than 1 over 8, and 1 over 7 is strictly more than 1 over 8, and 1 over 8 is equal to 1 over 8. So if you replace each term by 1 over 8 in this group, we get that this sum here is more than 1 over 8 plus 1 over 8 plus 1 over 8 plus 1 over 8 4 times, which is more than 1 half. Next group, which contains 8 terms, I replace 1 over 9 by 1 over 16, 1 over 10, 1 over 16 and so on. I'm gonna have 8 times 1 over 16, which is gonna be 1 half. And we see this terms, sum from 1 over 9 up to 1 over 16 is strictly more than 1 half, and so on. So if we pay attention in this generalization, we get that sum of first 2 terms, 1 plus 1 half, is equal to 1 plus 1 half, or equal to. S4 is more or equal than S4. 1 half plus 1 half plus 1 is more or equal more than 1 plus 2 over 2. S8, all this sum, is more than 1 plus 3 over 2 and so on. Suppose S partial sum of first 32 terms is more than 1 plus 5 over 2. In general, you're going to have partial sums of 2 to the n terms of this harmonic series is more than 1 plus n over 2 and so on. Sum of partial sums of 2 to the n terms of harmonic series goes to infinity, which means that proves that harmonic series diverges. Its limit goes to infinity. Okay? Partial sums of harmonic series. Theorem 6. If the series is convergent, then limit of an is equal to 0. Here's the proof. An we can write as a difference of n's partial sums and n minus 1's partial sums. So limit of n goes to infinity an is equal to limit of Sn minus 1. We can split, we know limit of difference is difference of limits, we write it here, but limit of n goes to infinity Sn is a s, and the same limit n goes to infinity Sn minus 1 is equal to the same limit s, right? So difference between them is 0, and this is a proof. Test for divergence. If limit n goes to infinity an does not exist, or if limit n goes to infinity an is equal to 0, then the series n goes from 1 to infinity an summation is divergent. Or let's just say this is a necessary condition. So series n goes to 1 to infinity an to be convergent, it's necessary, but not sufficient. That limit of an itself goes to 0.